In the very last proof, number 6, we're given that J is parallel to K and that K is parallel to L. So when we're going through this proof, we need to show that 1, which is all the way at one end, is congruent to 3, which is all the way at the other end. So hopefully you're thinking we're going to be doing some connecting and using some transitive when we're doing this proof. It looks a little bit daunting, but it's actually a pretty short proof once you get into it. So we're starting with angle 1. Let's start at the left side, and that's line J. I know that line J is parallel to line K, so I want to use some sort of connection between J and K where I can say the angles are congruent or say they're supplementary, depending on the measurements I have. Again, I'm working my way towards number 3. When I look at this, I think the easiest way is to say 1's congruent to 2 and then connect 2 to 3. We can work with all corresponding angles. So I know angle 1's congruent to angle 2, and they are corresponding. I also know, because K and L are parallel, that angle 2 is congruent to angle 3, also by corresponding. Remember, you can only say that for angles whose lines are parallel, whose two lines that create them are parallel. Again, I've already said 1's congruent to 2, 2's congruent to 3, so 1 is congruent to 3 by transitive. Now, sometimes you guys do these proofs and you make them harder without really knowing you're making them harder. Let's say you said 1's congruent to 5, 5's congruent to 2, 2's congruent to 6, 6 is congruent to 3. That's perfectly fine, that's completely correct. This is just the shortest amount of steps that you would use. If you did do it that way, or another way that's similar, you would just have a lot more connecting and eventually end up with the transitive property again. So this proof has a lot of different ways you can do it, but this is the shortest way.